Hello everyone, welcome to Learn Overflow. In this video, we will look into today's LeetCode problem, that is a convert sorted array to binary search tree. So this is an easy level problem, and we will understand how we can solve this problem, or how we can think of solving this problem. So before starting this video, make sure to subscribe to this channel for regular LeetCode videos like this. Also, every details about this question will be there in the description. Make sure to check that out as well. So let's start this. The question says that we are given an integer array nums, and the nums is the array that we are given over here. Fine. And it says like while the elements are sorted in ascending order. So the elements are already sorted. That we need to remember. The elements are already sorted. So the array nums given to us is a sorted array. Fine. In ascending order, and we need to convert it to a height balanced binary search tree. So it should be a height balanced binary search tree. And what does the height balanced binary search tree means? That it explains over here that the highest balanced binary tree is a binary tree which in which the depth of the two subtrees of every node never differs more than one. Okay, so it basically means like there's a tree, say there are two sides of a tree, the depth, that is the height of each of the subtree, never differs more than one, like the depth never differs one. So that's the whole thing. Okay, so once we, so the best thing is like how many like the number of elements, or the total height in this length is more or less equal to the height on this the other side. So for each of the nodes, so it may not be equal as well, like it can have a difference of one, but it shouldn't be more than one, like it should be like a huge difference in height as well. So it cannot be like it's only going on the right, it's only going on the right. So this cannot be a possible height balanced binary search. Okay, so once we are trying to find a solution like this, like where the binary search tree is in height balance, then how we can actually go ahead finding a solution in this case. Okay, we need to see and we need to see what the question gives us, and we need to see how we can actually think all the stuff given to us in the question. The first thing given to us in the question is the elements are in sorted. So once the elements are already in sorted, then can you think that if you have say you have a scale or a ruler in your hand, fine. So if you need to balance the ruler, you need to say you need to balance a ruler, that so that on your finger or on any object. Okay, so how would you do? You start with middle element, isn't it? Like whatever be center of mass, if the ruler will balance from that position. Fine. So if that is the concept we use in physics, now the similar kind of concept we can use in constructing the binary search tree, because we need to do that. It's a balance. This should be height balanced. Okay, so the first thing you need to do in height balance is you should whatever be the middle element, that should be the root. Okay, so like say there are five elements given to us in the nums array. In that, the middle element 0 becomes the root in any of the cases. Fine. So that's the idea in this. Now further, see, if middle element 0 becomes the root, then there are two elements on the right, there are two elements on the left. So you can start with the thought in mind that it's going to be balanced more or less. Okay, you are balancing the tree because the number of elements at least are same in both the side for the first root. Okay, next we need to go ahead and check for the next roots. Fine. Further, we find that there are 5 and 9, so you can start by taking like the 5 as the next root, and then keep 9. So that's more or less like the other solution given to us. Fine. What I mean is, like after taking 0, it's like the 5, you can take the 5 as the root and then try to balance the 9, or you can take 9 as the next root, or and you can try to balance the 5 on its left. Okay, so that's the idea. Now you may say like what happened, like it's how is it balanced? Look, from 9 the other side is null. Fine. That's what we know. So we says like it should be the difference should not be more than one, but the difference is what? The other side is 0, the here is one element. So the difference is anyways 1. So we know that this is like height balance because the difference is 1. It shouldn't be more than 1. Okay. The next case is on the left hand side. There is -3 and 2 -10. So you can go ahead with something like simply taking -3 as your root over here, or you can take -3 as root, and then take 10 on its left, and like -10 on its left and on the right, it should be is null. Fine. So you can take like that. Or on the reverse case, what you can take, you can go ahead with taking the -10 as a root, or and -3 on its right. So this may happen. Okay. So the question itself, like the explanation tells us like the both the solution can be an accepted solution. So that they will accept both the solutions. Fine. So there won't be any problem related to that. How can you think of finding a solution like this? Okay. The thought process is pretty simple considering the what I initially gave examples at the center of mass of a object, okay, the center of gravity, what do you say? How we go ahead with that? The idea was just find the total number of elements, okay, and find the middle element at each position. So if you find the middle element, make this your root, and then go ahead with the all the elements on his left are his left subtree, all the elements on his right are his right subtree. So that's the idea. Okay. And the next case, when we are in the left subtree, so what is the middle element? Middle element will be 0 plus 1, but that's 1 by 2 is like 1. So middle element comes up with 3. Okay. So -3. It doesn't matter. You take -3 or the -10 because both the way it's an accepted solution. Fine. So now we find that it's -3. If we take the middle element, this comes out to be -3. Fine. Now take the -3 and take -10 as its leftwards element and null as its rightwards element. So that's the whole idea. Okay, that's the idea. Just on each of the pieces or each of the subtree, just take the middle element, whatever element on its left are its left subtree, whatever element on its right are its right subtree. So that's the whole idea you need to follow to come a solution to this. So we'll follow the same thing and write a code based on that. Okay, we'll exactly do the same thing and write a code. So that will be our idea. So let's go ahead and write our code, and then understand how we exactly try to follow what we wanted to do in this question. Okay, let's go ahead with that. See here, the particular solution we came across is actually is again a 0 millisecond solution. It's faster than 100% Java solutions. Okay, let's understand what a solution we came across over here. The solution is exactly the type we were discussing till now. The idea was we took another like helper function with the same name but the different parameters. So it's like a function overloading is going on. So what we took the nums array, we took a start and the end. It was just the index to point what's the current start and what's the current end. Okay. So if the start is greater than n, return null. So what this condition is, whenever we need to add a null value to any of the roots, okay, any other subtree. So that's the this will help us in that. Fine. Now, further, what we did, we took a mid. As said, we will take a mid, and mid is basically finding the middle, like the middle element from the start and end. Okay. So that's the how we were calculating the mid, and then what we are doing, we are just doing like we are creating a tree node, like your current node, and that node is basically tree node is basically we are creating a new tree node, and that's the value we are giving it as tree nums mid, the mid value, whatever the mid pointing at. So we just gave it a nums mid. So which constructor we are using is in the like commenter section. You can see the constructors are given. So there is a construction like this one. So like tree node int val, if you just enter val, So this will initialize the current value of the tree node as like the val or whatever val we are passing it through. Next, we just went ahead with that root left as the root we created, and the root we created. So we just went ahead with the root left and root right. So root left is again calling the same like the same function with a different parameter like the nums array being sent as it is, and the start being the starting till the we're on the left side, so it will be like starting till mid was initially zero, like this element was initially mid. So what we did on the left, we said start till mid minus one, because mid is that just the pointer we had. So start to mid minus one, and on the right, what we are going with mid plus one till end. Okay, so that's the whole idea. That's the whole idea. We just break it in that format, and we found that this is the ultimate return. We are returning this root. So once in any case, say on the left or on the right, we don't find a expect a solution, or we don't find any particular value that's lies there, so we end up with that as a null value. Okay, so that's the whole idea. That's how the question, like we are trying to solve this question, and you folks already saw that the question works pretty well as a 0 millisecond solution. Fine. So that's the more or less the idea behind this question. I hope I can make you understand how you can go ahead and solve a question like this. Fine. And you should try this question, and definitely, if you face any problem understanding this question, make sure to comment it down. I'll be more than happy to help you out in the comments as well. Fine. So, I like this video for making me understand that you actually you find this video helpful for you as well. Comment it. If you face any doubts, or if you just want to convey any other approach that you have in mind, I'll be happy to read that and communicate with you as well in the comments. So that's more or less about this video, guys. Thank you all for watching this video. Make sure to subscribe to this channel for regular LeetCode videos like this. I hope to see you soon in my next video as well. Thank you.